I'm going to teach you some new notation today. It's very important that you get comfortable with this notation. We're going to describe what is called the left and right hand behaviors of a graph. Let me move that up. Sorry about that. The left and right hand sides, or the left and right hand behavior of a graph, using some new symbols. For the left side, I will use this notation as x approaches negative infinity. What you have to get comfortable with is this is a hieroglyphic statement, it's not a direct statement. We never, ever, ever change the direction of the arrow. The arrow is not a direct picture of what's happening. I read the arrow as x goes the direction of, in this case, negative infinity, which tells me to the left. If I want to say the right, I do not flip those pictures at all. I write it the same way for the right. As x goes a direction and the right is positive infinity. This is very much like writing a sentence. If I want to say Johnny is walking to the right, I would write it just like it sounds. If I want to say Johnny is walking to the left, I would not write my words backwards. That would be incorrect. When we write a sentence, it has to flow from left to right, and the symbols always are used in the same way as we read and write from the left to the right. So, let's take a look at why we would use these. If I want to describe the left and right hand side of behavior of a graph, let's take one graph and we're going to describe its left and right hand behavior. This you should recognize as, if it's a power function, this is a power function, it's odd, its lead coefficient is positive. Those are things you can get by looking at the graph. Now I want to talk about what's happening on the left and right. So, as x goes to the left, I would answer this by saying f of x, or y, is going, well, let's take a look. As I'm going to the left, y is going down. I would answer the direction down for y as negative infinity.
So it's basically saying all real numbers?
No. It is not like saying all real numbers. It's a direction. This is an up or down direction. So I'm saying, listen exactly how I'm reading what's written up there. As x goes to the left, the y values are going down. That's how it's read. Now I'm going to say as x goes to the right, as x goes to the right, what's happening to my y values? The y values are going up. Everyone good with this? Let's do another. going to start it off the same way. As x goes to the left, well, y is going down, but it doesn't look like it's going down forever. In this case, y is actually approaching a single value. Y is approaching 0. So as x goes to the left, y, or f of x, is going to 0. And if I look at as x goes to the right, I can say y, or f of x, is going also to 0. So I'm talking about the left and right hand behaviors of the graph. They don't have to be going up or down forever. In this case, both of the left and right hand sides are going down towards a specific value, 0. So it's all about using the notation. We're going to add some more notation. Yes, ma'am. Okay. We're going to describe everything we can from the graph, given that the graph is of a power function in the form f of x equals kx to the p. I'm going to first of all start by talking about p, then I'm going to talk about k, and then I'm going to talk about the left and right hand sides. So first thing, p. P has to be even, yes. How about, is P positive or negative? Positive in this form if it's direct variation. Negative would be inverse, and it would be the two splits. So P is positive in this scenario. So I know it's an even exponent, and I know it's a positive exponent. Now I'm going to talk everything I can about k.
K is negative.
In this case, all I know is k is a negative number. Now we're going to talk about the left and right hand behavior. Now we're going to talk about the left and right hand behavior. As x goes to the left, I can see that y is going down. But also, as x goes to the right, the y, or f of x, I'm looking over here, as I go to the right, y is still going down. Okay, one more scenario. I have a power function and I'm given its graph. I'm going to describe everything I can about this power function. First I'm going to talk about P, then I'm going to talk about K, then I'm going to talk about its left and right hand behaviors. So everything I can tell you about P. First of all, notice how the graph is going in the same direction on both the left and right hand sides. That lets me know that P is even. Notice how it's heading on both sides in the down direction. At least part of the graph is going down. That tells me that P is negative. So I've got that going same side. If it's broken in two different pieces, tells me that P is negative. K is negative also. Left-hand side, as x goes to the left, y, or f of x, is going towards 0. as x goes towards the right, y, or f of x, is going towards